Everybody knows fruit flies. They're the little pests that land on your food right as you're about to take a bite. What you might not know is that flies are commonly used in biomedical research due to the large share of disease-causing genes they share with humans. They also exist in almost every place on Earth and are critical parts of our ecosystems. However, flies are rarely looked at for the complex beings that they are and how they exist as animals in nature. As we prepare for the future of the planet under climate change, these tiny creatures can give us valuable information on what our changing ecosystems may look like. My lab has been working with farms and collecting flies from all over the East Coast. Once we have those flies, there's a lot we can do with them. But first, we need to use some carbon dioxide and put them to sleep. Don't worry, they'll wake right back up. For this experiment, we'll be looking at their genes to see differences in different temperatures. We grow these flies and expose their eggs to a high-temperature heat bath to simulate heat waves. From this, we can find the versions of genes that are more common in embryos that survived this heat versus the ones that didn't. Using our supercomputer, we were able to find a few specific genes that have an increased frequency of a small mutation, the hotter that it gets. This occurs naturally both as it gets hotter in the summer and as you go more toward the tropics. We find that the heat-shocked embryos also exhibit a high frequency of this gene, even if they're originally from colder areas. And that's where I come in. Hey, I'm Corey. I'm a grad student at the University of Vermont, and I'm looking at what exactly these genes are doing that allow these flies to survive sudden heat waves. We know that these genes have a role, but we still aren't sure exactly what's happening that's letting these embryos survive. I'm looking at the molecular level to see where and when these genes are being expressed in order for us to better understand what's going on. One way I'm doing this is by tagging the RNA from these genes with fluorescent tags. That allows me to see where and how strongly the genes are being expressed. This will help us predict how animals will be adapting to increasing temperatures, because knowing how these genes work in flies can give us direction for how they might work in other animals. We're all related after all.